Diamonds are a symbol of romance. Many people seal their love with these gleaming gems. But beyond their beauty, diamonds possess unmatched hardness. Cutting metals and shaping gemstones, diamonds handle it all. It doesn't end there. Diamonds can even be used for electronic chips. Yes, you heard it right, electronic chips. But at first glance, it seems that diamonds don't transfer much electricity. You're right, they don't until we do something. Diamond, like silicon, is actually a semiconductor. Semiconductors are more conductive than insulators such as sheets of paper and less conductive than conductors like metal spoons. You can picture semiconductors like diamonds as highways with few cars. The reason they don't transfer electricity well initially is that there are not many cars to begin with. Once cars start driving on the highways, they can move super fast. All we need to do is introduce more cars onto the semiconductor highways by mixing in impurities. Plus, insulators are like unpaved country roads covered in gravel. They don't have many cars traveling on them in the first place, and even when cars do venture on these roads, they cannot move very quickly due to the bad conditions of the roads. Alright, back to the semiconductors. There are two types of cars, electron cars and hole cars. A hole acts as a positively charged particle, which is actually the absence of an electron. They go in opposite directions because they have opposite signs of charge. First, add a lot of electron cars on this side and hole cars on the other. If the traffic signal is set right, they can speed in opposite directions. If the wrong traffic signal turns on, they'll try to turn back. However, the dense traffic behind them prevents them from moving in the reverse direction. Yes, this means that electric currents are allowed in only one direction. This is called a diode, which is the simplest electronic device. Okay, now we know the diamonds can be used in electronics. Why is it so special compared to silicon? Diamond highways have much harder and safer guardrails compared to those on silicon highways. Let's say many electrons are trying to get onto the highway. On the silicon highway, the guardrails are so fragile that the electron cars might break through and flood the road. This often happens when an excessive voltage is applied to silicon electronics. They cannot control the flow of electrons and stop working correctly. Diamond highways can withstand much higher traffic pressure. In other words, diamond electronics take control of insanely high voltage. We can use diamond electronics in high voltage systems like power plants and electric vehicles.